Yes, thank you.
Okay, I'm sorry. I took it. Uh, one of the students asked me if you want I record the lecture and then upload it, and he's a full-time student, so if you want to see my lecture later. Honestly, I have not talked by the senior professors yet, so the senior professor is very sick. So if he allow, I plan to record my lecture and upload it. But if he, because it is a synchronized class, so last time he said to attracted the students attend the class, he suggested he didn't recommend I record the lecture for the absent, but I will talk with him later and then I will decide whether I will record my lecture or not for the absent student. Yeah, I think there is a three students cannot attend this class because they are full-time work in the same ways, and one of the two students they are working in San Francisco, I think. Anyway, uh, let's start class. What is? Let me share screen. Okay. Hmm. Did you see my screen? Can you see?
Yes,
Okay.
Yes.
Okay. Thank you. Um, last time, the engineers wanted to the properties of mechanical properties of materials, so they studied the measured uh, stress and strain curve. But when they study the stress and strain, uh, at the first time, they just focus on the initial cross-sectional area. So they just focus on calculated stress and strain curve based on the initial cross-sectional areas. But they recognize the area, cross-sectional area could be changed. So they introduced the two strain and two stress. So two strain and two strain can explain the stress in the force by the very small, the smaller size areas. Um, However, the engineers wanted to focus on the just pointed the force and the pointed area or pointed a very small surface. So they started, they're gonna decompose the force according to the directions. So we can understand the stress or mechanical properties easily, and then we can design the kinds of the plane or boundary conditions according to uh, the specific case. Um, this is the reason why we study the tensors last section. Um, and then today I would like to study the transformation of the stress. Okay. There's a lot of the pressure or torsion or compression, tension or bending in the mechanical system. So we need to understand the or how force affects the materials. So we can design the materials, apply the load or stress. And then based on that, we can design the materials or structures if they are potentially. Honestly, I would like to share one of the examples. Um, we are, okay, we are the mechanical engineering and aerospace. So I would like to show the one of the example, just the example. Um, 5 years ago, the one of the plane was crashed in Mexico. This is the Aero Mexico 52431. Do you know how it was? They're gonna fail to rhyme, but is the do you know how many people died in this crash? There is no people died in this crash. There is a lot of the reason, but one of the reason is engine could be detached from the brain body. So brain, even what is there is a lot of gears in the wings, but engines detached by some of the stroke was the suppose. So because of the detached engine, there is no big fire. There is some fires, but it's not explosion. So people can escape after crashing, and then all people can survive. All passengers can survive. So we need to so engineers should design the materials. Sometimes engines could be attached under the wing, but some parts of what is upright, the engines should be detached, and then there is no any other explosion or some of the case can be prevented. So if engineers work, this is one of the engineers work. So we need to understand how to this. We need to understand the force and then upright force, right? And then we can design the materials carefully. Okay, so this is a stress and tensor we studied before. But in this course, we are going to focus on the only the two, what is the 2D uh, plane, 2D plane. So if we consider the XY plane, we can say sigma XX, tau XY, and tau xy and sigma yy. And if we consider like the z plane, the matrix could be explained by sigma xx, tau xc, tau zx, and sigma zz. And then if we focus on the the what is gy plane, tau sigma zz, sigma yy, and tau zy, tau yz. In fact, tau xy and tau yx is equal. They both are equals because if it is not equals, materials could be rotated. So it should be equal, so we can write down like it. I'm going to move on the transformation. So if the force direction is transformed, how we define how to make it a relation between two matrices. I will explain about that. Then, so first, this is almost a mathematics class, so let me explain. So we are going to calculate the x prime direction force and prime direction force. This direction first. So in this direction, sigma x in this direction, sigma xx, and area is related to the fx direction, right? X direction. It is equal to this direction forces, the initial xy direction, xy direction forces. So tau first, tau yx described like that. I'd like to explain the area first. This is the area of the yx plane, and this is the A area, and it is related to the this is the theta, so A equal so A and A. I just define just the xy plane is equal to sine theta, right? And sine theta. So we can sine theta. So it is we can rewrite like that. Okay. We write like that. So tau yx, yx, and the area A is A sine theta. And then we can explain, we can focus on the force. Now, okay. How y is direction is like that. And then sigma x direction is like that. Okay. Okay. So sorry. So if we define like A, this is the yx, 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 and then if this is easy to make if we make like it, this is force how I x, but direction, since direction is changed, we just mention minus tau. Then, because this is a theta, this angle is theta, so it is explained how I x cosine theta is, this direction force is how I x cosine theta. Do you understand? So this term could be explained by this relation. Then tau xy. Tau xy is this direction, and we want to see this one, right? So we can change. It's up to you. It's if you can change the direction like it, you need to change the tau minus tau xy. Then since what is this is a theta. This is this is 2 pi minus theta. 2 pi minus theta. So using the like the relation of the sine and cosine relation, we can calculate it a tau xy a cosine theta times sine theta. Do you understand? Do you need more explanation about that? Feel free to let me know if you have any difficulties. Can I move next? Okay. So and then sigma xx is this direction. So we can calculate it, sigma xx, and it's very similar to the tau ix calculation. So sigma xx and cosine theta. And then it is this area is related to a cosine theta. So we can a cosine theta. Then sigma yy is this function is exactly the same with tau xy. So area is a sine theta, and sigma yy is sine theta is related to the x prime direction. How about the y prime direction? So y prime direction is also related to this one. I think you can calculate this one similar to this, similar to the x direction calculation. Okay. So we this relation could be changed to be right like that. So it's exactly the same to this one, sigma xx, sigma xx, this one, and this one. Then tau ix is explained. Tau ix is from this here. So if we kind of the 90-degree case, we can just since is x and y, the direction is 90 degrees, so we can rewrite the y sigma y prime by just plus pi over 2 further. Then we can write it. We can obtain the these relations. Do you understand? Okay. To make a more simplified relation of the sigma x prime and sigma y prime and tau x prime y prime. These relations would be rewrite like it's more simple thing. So, and it's the kind of the like, uh, kind of a mathematics problem. So if you wanted to how to derive this equation from here, just feel free to let me know. I'll let you know. But cosine, but it's very easy. So cosine 2 theta is cosine 2 theta is equal to cosine square sine square theta and minus and sine square theta. So it is from here, and then there is if we also just there is I think that there is you can multiply one. One is related to this. So here is this relation and here is this relation. So if we use this relation, we can obtain the same equations from this case. Okay, so next, the important thing is if we change it, if we change if we perform the transform of the sigma x's, sigma yy, and tau x's, xy, the sigma x prime and plus sigma y prime, it should be equal to sigma xx plus sigma yy. If it is changed, is our calculation would go wrong. So quantity is invariant. And then so we can what is let me just to skip this one in this step. This is not a important here, but what is it is important to very useful for the three-dimensional transform. But in 2D, I think it just simplify the previous equations. Okay, so if we have the stressing, so this is the equation of the sigma x prime, and tau x prime and y prime. So, so if we transform the axis by theta, sigma x prime is changing right click, and tau x prime and y prime change to right. So we can obtain the this plot. So tau mean is defined here, tau max defined here, and sigma x prime, sigma mean is defined here, sigma max defined here. Okay, so we can calculated the minimum and maximum of normal stress and minimum or maximum of shear stress based on these equations. So based on this equation, we can derivative this equation by theta. So this point, this component could be on, there is no theta, and then this part 2 theta is the cosine 2 theta is changed to minus 2 sine theta. Yes. And then tau xy to sine theta is changed to 2 tau xy cosine 2 theta. I think you can drive this equation very easily. So based on that, I think the maximum or minimum of normal stress could be generated at this sigma this theta is 0. So we can get a deceleration. Then, in case it's same to the shear stress, we can calculate it maximum and minimum shear stress. If you differentiate these situations, and can get these relations. And then maximum or minimum shear stress could be generated when t tau d theta is 0. So we can calculate it, we can obtain these relations. The average, just one more thing is the normal stress average is calculated by just the mean calculation. So, and the shear stress in case of the normal stress is calculated by this one, and this mean is average normal stress. If there's an average normal stress, then maximum is plus, minimum is minus, and how max we calculated could be expressed by these equations. So more circles would be more circles studied developed 4 years ago. No, 100 years ago. It could be 104 years ago. So I think it is very useful when we design and understand the material properties. So we can get the deceleration, right? The decelerations, and if we change the relation like this, we can draw the most circles first. So this is the average. So just then we can rewrite this relation like it is. Sorry, it is very similar. See this part. And if we can see this part, if we can see this part, scared, scared, scared. So it is changing with white like it, scared, scared, scared. It is very similar to the circle equation. So in this case, the center is located as 0 and radius of this circle has r. So based on this information, we can make it the most circle center as what is the normal stress, average normal stress. Then we can, what is the radius of the most circle could be defined like it is the, what is the shear stress max, or R is same to the average, what is the sigma, what is the normal stress is the same to the average normal stress plus radius. Minimum normal stress is equal to the average, the average stress, normal stress minus the radius. So we can understand the mechanical properties very easily. So I would like to explain how to construct the most circles based on the obtained normal stress and shear stress. First, you can make a cube with normal stress, 2 normal stress, and 1 shear stress. Make it. You can make it a soft cube and rotate it sigma xx, tau xy, sigma yy. Then make it write down the frame V and put the frame H, right? H and V. Then H and V has the V is sigma xx minus tau x y. That's very important. Minus. H is sigma yy and tau yx. The reason why we just use the minus tau xy is we are going to make the same direction of the shear stress. So at the time, we just focus on the clockwise, the rotation of the cube, clockwise rotation of the cube. So we mentioned then so HV and HV then through the horizontal axis, the normal stress to right and compressed normal stress is left at negative. And through the vertical axis, y direction and shear stress, clockwise and rotating down. So like it means this one. So counterclockwise, that kind of it and sigma 2. Then locate point VH, label the VH intersect C is average normal stress. There's no more stress. So at the time we can make it. I'm sorry, it's H, B, and pointed the normal stress, and then we point out the axis X intersect area with sigma max, sigma 1, and sigma min is equal to sigma 2, and we draw the both circles like this. So this, and then we can calculate the radius, we draw the radius like it, and we can make it both circles. Do you know how to draw it? So it's just that if you get it, this is a not sure the explanation, but if you once you get this what are these relations, you can easily draw the most circles. If you draw honestly, if you draw this equation first, then you can easily point out the center position of the most circle racket. Then it is defined what is average normal stress. Then you can draw the circle using the radius defined by racket. But the problem is that some text or some text draw the racket. One is the shear stress axis is going down. At the time, you need to change it. So when you work in industry or when you work with student later, please keep in mind or please carefully see the direction of this one. Okay, I'm going to move on the exam problem. So, please consider the point solid is objective to the following statement of stress. So sigma xs is 90, sigma yy is minus 80, and just stress is minus 60. So I would like to give 2 minutes or 3 minutes. Please draw the free body diagram. The do you know free diagram? And it's just like this. If you do this one, and then you make the sigma yy and there and x and there's one more. 4 tau x y. So please put the number in here. This is kind of the diagram. Is this y. Is this section and this opposite section. So please put the number here. So sigma xx is 90 megapascal. So this is 9. Oh, no. This is. And yy is minus 50. This is minus 50. And it is minus 60. Is it correct? Yes. 60. Okay. Okay, this is the kind of diagram. Then determine the principal stress and the maximum influential stress on the point, gravitational plane, principal plane using most of course. Can you calculate this one? Can you try? I want to give 2 or 3 minutes. And just it, just it. We is so based on the definition of V, we can write down the vector like 90, 60. And how about the H? It is Y is positive XY. So it is explained by minus 50 and minus 60. How about the C, center position? C is everything and 0. So we can have 2 9 plus minus 15 Okay. So I think you can calculate this one, I believe. So we can calculate R equal to 25. Mhm. Mhm. Could you please calculate this one? Did you get it?
4,000.
I'm sorry?
4,000.
4,000?
My bad. It's in scale root, so my bad.
Oh, sorry. This one, there's the negative. Oh, my mistake, sorry. This is the. Please calculate again. Not both sides. Both sides.
I believe it's 92.2.
9,
92.195.
9.195.
5.
Great. I trust you very much. It is same to how makes just makes it, because you can see the distance just as mass is equal to the radius of the Mohr circles. This is okay. I'm going to move on the 3D transformation. 3D transformation is more complicated. So I'm just to assume. But do you need more time to write down the sorry, I missed the diagram. So based on that, you can draw the most circle racket. So let me, if you have the how we make value and so all right. Okay. So This is the center, I think. So C is 20, 0, then we can calculate. This is R, our max point. This is the sigma 1, and this is sigma 2. So, and rated this is sigma 1, sigma 2. Can you draw the smooth circle? I think we are better than me. Yes. R and it is 92.195 is sigma 1 sigma 1 is equal to sigma average z sigma average z plus R is we just calculate this one also. Sigma 2 is R, and please calculate this point. Okay. And then here, this is a V, there's a V, it is 90.6. It's quite. And then 8 minus 50 minus 60, right? 50, 50 minus 60. This is the center. C is 1, 0. Could you please calculate this one? Sigma 2 and sigma 1. Then if we here is the theta. If this is theta, so finding 2 theta calculated by xy how xy and minus sigma xx and sigma equal. So it is how it is 60, I think. And then 1 is 70. So please calculate two sets. So set equal so you can do this one and this. What's the value of the sigma one? Do you know? Do hello? Okay. No.
I got 112.125.
Oh, I'm sorry.
I got 112.125.
112 and point
0.125.
0.125. And what's the value of sigma 2? Minus
Right? Yeah, negative 71.125.
71.125.
125.
Thanks a lot. And how about theta? How about the theta? Did you get a theta?
For theta, I got 40.60.
Point 40?
40, yeah.
Be careful, this is just
Oh,
theta.
I forgot I got the times that by 2. So 81.2.
81. 81.
81. 81, yeah.
81.
Unless I did this one. I probably did it once. Hold on. I forgot my calculator. So I've been doing my phone's calculator.
81. It looks like this one. Mhm. So So it means this is theta 2 is it's value minus 71. 0.571, 21, 2, 5. And this one is 1, 2, 5. 1 to 5 is 1. That's the answer C. Here's a setup. It's just 81. 81 is too large than I expected, but anyway, it is this is the please recalculate this one. It's a little large. Because this is 6/7, so anyway. I think 20.3 is more reasonable. Hold on. Please double check the setup. Let me.
I actually got 20.3. I accidentally multiplied by 2 instead of divided by 2. Professor, you're muted right now. I don't know if you are aware.
Oh, I'm sorry. I'm sorry. I thought a lot. Okay. 20 is more reasonable. I think once you get the 40, you can just get a 20 by divided by 2. So this is a 20. This is a 20.3. Yeah. And then I'm so sorry about that. And then I'm going to move on the 3D transformation. Oh yeah, this is the answer of the C. So we can get the Moore diagram and then clearly see the meaning of the Moore diagram like that. Then we are going to move on the 3D transformation. 3D transformation is more complicated. As you can see, if there is a normal stress, in case of 2D, we just consider two components. But in case of the 3D, we need to consider the lots of the components, the 3 components, and then they have the different angle. Is based on the X direction, Y direction, and Z direction. So we need to consider everything, and then we can derive the equations again. So I think, yeah, just to briefly explain the 3D transformation, and then I will re-explain again next Tuesday. So firstly, what is the normal stress vector? The angle between normal stress vector and X direction is defined L cosine theta X, and this is of course M defined by the angle between cosine theta. The theta is defined by the angle between Z direction and normal stress vector, and then M is Y, and N is the normal stress vector in Z direction. So we define the L, M, N as the cosine direction. So using this relation, we can derive the more complicated relation method. Let me explain this part next Tuesday. Then I want to start today's session now. Do you have any question about the 2D transformation?
Question.
Do you have any question? Okay, thank you. And then next Tuesday, please kind of the note or the summary note for the 4 lectures. Then you don't need to spend lots of time for these courses and focus on your work and on your studies. Okay, thank you. If you have any question, please let me know. Okay, thank you. See you next week.
Thank you.
Mhm.
Thank you.